Hey, fifth grade. So today we're going to look at how you can use your number sense or your understanding of numbers and place values to multiply decimals. So if you've learned to estimate when multiplying with decimals, we've done that tried and true strategy that I taught you where we drop the decimal, we would multiply it without a decimal. So if we had 4.34 times 5, we would do 434 times 5. Then we would do this interpretation where we move the decimal to the left from the ones place to the right of the ones place. We move it to the left how many decimals you had in your original factors. It's a great strategy. You've used it a lot, but there are some times where you could make some snafus or some mistakes. And so it's important to really think about these numbers. So let's look at this equation right here. 49 and 20 hundredths times 55 hundredths. Well, that is going to give me a product that has 2706 in it, but we have to think of what is the decimal because it's not 2706. So the first thing I want you to consider is your factors themselves. So I'll circle my factors and the relative size of my factors. So we have 49.2, that's close to 50. And when we have 0.55 or 55 hundredths, that's really close to 1/2 because 0.5 equals 1/2. So with that knowledge, we need to really consider what we're multiplying here. When you multiply a number by a decimal that's less than 1, so if it has a 0 in that one's place value, it is less than 1. Anytime that you do that, the product is actually going to shrink from the other adjacent factor. So that's going to, when you multiply this by 1/2, it's going to shrink this factor. I know in multiplication we are so used to our numbers growing, but when you multiply those products and find those products of decimals less than 1, it will decrease actually the size of your final product. And since we know that 0.5 is about 1/2, we would probably be looking at this number being half of 49.20. And what I mean by this number is the final product. So that final product is going to be about half of 49.2 because we are multiplying by a decimal less than 1. So if I think about that, let's look at our numbers here that we have and interpret the decimal. So in today's lesson, you're going to construct arguments and you're going to have to decide if the decimal place is correct or incorrect in the problems that they give you. They're going to give you the factors and they're going to give you the product. You're the one who's doing interpretation of the decimals. So if I knew that this is going to be this product about half of 49, so half of 50, it's going to be somewhere around 25, I think, of my change. 25, 50, 75, 100. That's a good benchmark for me to really think about this. So looking at that, where would my decimal place go? Well, that wouldn't help us because that's a number in the thousands. That's 270 and 6/10, so that's not half of that. 27 and 6/100 looks about half of that. That could be my correct answer. But I'll go over here and look at the 2.700, so 2 and 706 thousandths, or 2.706. That is way less than 1/2. So my decimal should be about there. So an alarm might be ringing in your head right now, and if it is, I'm very proud of you because I taught you to count the decimal places, and you have 1, 2, 3, 4. And if you did that method, you'd move this 1, 2, 3, 4, and you would have a number that is very different than the correct answer. And why? Why did that happen? Let's look at some reasons why that method failed you in this circumstance. So first of all, 49 and 2/20 hundredths is really 49.2. You can drop that 0 because 20 hundredths is the same as 2/10. And we have to regroup that, we have to bundle that up. Think of whole numbers. We don't say we have 10 tens. We say we have 100. We don't say we have 20 hundredths. We say we have 2/10. So that's one of the reasons why that you have been impacted by that strategy. So let's look here. If we did that, we'd have 1, 2, 3 decimal places. Well, going back to that, 3 decimal places, if we looked at it, 1, 2, 3, we're still getting 2.706 is my answer, which is incorrect. So again, what is going on here? Why is this not working for me? So let's look at the strategy that I taught you with dropping the decimal, multiplying, and interpreting. These sticky notes have come in handy these last couple of days. So I rewrote 49.20 times 0.55 as 4,920 times 55. And when I solved that on my calculator, because for sake of time, I'm not going to show you that long multiplication steps, you actually get 270,600. And you look at the answer that was given to us was 27 and 2,706. And that came right from your book. So in the book, what they are doing is they're simplifying some of these problems because they're just using place value, not that strategy that I taught you. And that's where you're going to get into have some challenges. So if I did that, if this was how I multiplied it out, and I looked at my 4 decimals, 1, 2, 3, 4, and move my decimal point 4 to the left, like I taught you, 1, 2, 3, 4, you get your final product as 27.0600. Okay, just like the example I showed you with 49.20 really being 49.2, this one right here, you don't need these zeros at the end of your decimal. You could cut it off at the very last decimal place that has a whole number that's greater than 1. I'll repeat that. You can erase and cut off your zeros to the right of the decimal place value that has a number that's greater than 0. It's that whole regrouping concept that we just talked about. And that's how you would get 27 and 6/10. So this is a good hypothetical situation where number sense plays a big role in understanding these type of problems. And it's challenging and it's some brain work. And I know that it makes some of you feel like this. But think of growth mindset. You can easily feel like this if you just take the time to process and work these out. Let's look at another example from your book. We have 6 2/10 times 5 1/10 equals, and they give us this number right here, 3162. So where does my decimal point go? So how can you place the decimal point in the product in the equation below? Because you're giving me the equation, not the expression. When they have an equal sign and an answer, it's an equation. So notice the smallest unit in both factors is a tenth. So the very smallest place value for both of these factors are tenths, correct? Since the product of 1/10 and 1/10 is 1/100th, think about that, 1/10 times 1/10 equals 1/100th, right? We multiply across. 1 times 1 is 1, 10 times 10 is 10. When you multiply a tenth and a tenth together, your number is actually breaking into smaller pieces. It's 1/100th. Since that product is 1/100th, the product of 6 2/10 and 5 1/10 will have to have 2 decimal places. So again, using our tried and true strategy, you see 1, 2. But this is conceptually why. When you have a tenth, when an object is split into 10 pieces, and then you split it into 10 more pieces, you're going to have 100 total pieces. So we would move this to make sure that this decimal had numbers in the hundredths place. So if I put it here, that's a whole number. That's a number to the thousands place. Here we only have a tenth. Here we would have a number in the hundredths. Just to check it though, Now we would have a number in the thousandths, and then we would have the next place value over, which I believe is 10 thousandths. So it would be 31 and 62 hundredths. So my challenge to you today, mathematicians, is this. I want you to think very, very, very deeply of what the factors are telling you. Read the factors. Think about two key concepts here. The first concept being if that is less than 1, that decimal is less than 1, your factor is going to shrink. I'm sorry, not your factor. Your product is going to shrink from the factor. That was the example that we gave you, the first one, where we multiplied 49 and 20 hundredths times 0.55. This is less than 1, so my product will be shrinking from this number. So that's a key concept to remember. The other concept to remember is this idea of these decimal places after, these zeros after the last decimal place value that is greater than 1 can be dropped. I'll say that again. When you look at the last place value that has a number other than a 0, so a number greater than 0, 1 or greater, you can drop those decimals to the zeros. And when you get into chemistry and you start to do some scientific math where there are not precise units of measurement, that'll be essential. Good luck, mathematicians.